Hello, today me and my team members will present our research project be about monitoring system for hybrid power system in Grey River, Newfoundland, web-based SCADA approach. It's presented by Muhammad Kandil, Muhammad Ali, and finally Muhammad Akl. The project was supervised by Professor Tariq Iqbal. Finally, this research paper is in the approval phase for the Jordanian Journal of Electrical Engineering for publishing. Presentation consists of introduction, methodology of the project, results of the project, and finally the conclusion. The page number of each subsection of the presentation can be found on the right of the table of contents.
SCADA stands for Supervisory Control and Data Acquisition. It's a type of software application program for process control. SCADA is a central control system which consists of controllers, network interfaces, input-output cards, communication equipments, and software. SCADA systems are used to monitor and control the equipment in the industrial process, which include manufacturing, production, development, and fabrication. The general SCADA system can be classified into two parts: client layer, data server layer. The client layer, which caters for the man-machine interaction. The data server layer, which handles most of the process data activities. Most of the servers are used for multitasking and real-time database. The servers are responsible for data gathering and handling. The SCADA system consists of a software program to provide trending, diagnostic data, and manage information. Its scheduled maintenance procedure, logistic information, detailed schematics for a particular sensor or machine, and export system troubleshooting guides. The proper management of energy systems includes process modeling, process optimization, hardware and software, suitable setup design, and monitoring operation. New energy strategy development is a common topic of scientific and industrial research. The complexity of energy system modeling increases when many variables are involved. The complete integration of renewable energy sources into sophisticated grid systems considers the deployment of sensor and storage systems and the potential to cutting-edge data processing methodologies. Because of this, many conventional instruments, including multimeter, are employed in this situation. However, when the environment is rapidly changing, it might be challenging for a human to accurately read these devices. So far, a real published paper explored hybrid-power system based on PV solar panels and diesel power generation system in Grey River, Newfoundland. Thus, this project aims to develop an experimental low-cost open-source SCADA monitoring system for a remote hybrid power system.
The monitoring system would be implemented by measuring the DC line of the circuit powered by a battery and the AC power supply, which in theory should measure the lines of the previously proposed power system. Arduino Uno would be used to form the connection between the voltage and the current sensor and the node server on the computer to measure the current and the voltage. As the sensors would take the readings from the PV panels, the readings would be direct current and alternative current. This is done to monitor the power outcome of the previously hybrid power system for Grey River and Newfoundland, including the PV solar panels which provide DC power and diesel generator which provide AC power. The Arduino connects to the node-RED and is implemented through the serial port COM4 port. The process real-time data is then displayed through the node-RED local dashboard and is posted to a web server that can be accessed remotely. Arduino Uno is an embedded board that is used in this research. ATmega 328 is an integrated microcontroller in the Arduino which is programmed through the Arduino IDE software. It has 5 input analog pins that are labeled from A0 to A5. In the test setup, the DC voltage sensor module can measure voltage up to 25 volts. However, the Arduino can only measure up to 5 volts. As a result, the output voltage sensor, which is linked in parallel with the load, is received by an analog digital converter ADC of the Arduino microcontroller. On the other hand, the AC voltage sensor has a mini transformer that reads peak-to-peak voltage value and then transforms it to RMS value. The current sensors have a precise, low-offset linear Hall sensor circuit. A magnetic field is created when an applied current passes through the copper conduction path. This magnetic field is sensed by an integrated Hall IC, which then converts it into a proportional voltage which Arduino can calculate the current. The DC bus side is measured from PV panels, while the AC bus side is measured from the output terminals of the inverter. The Arduino was programmed through the IDE to measure both the DC and the AC current and the voltage of the system with an interval of 5 milliseconds. The measurements would be sent to the serial port and the local monitor of the Arduino IDE, and then the process would be repeated. The whole process duration is 1 second. Therefore, the measurements would be taken on an interval of 1 second. This was done to minimize the memory of the database and increase the practicality of the system, as it should be operated uncontrolled for a long duration of time without human interference. Furthermore, Node-RED is a Node.js-based, open-source flow-based IoT platform and a dashboard created by IBM. Arduino is coded to form a delay between each reading with an interval of 5 milliseconds. The connection between the Node-RED and the Arduino is configured through a serial port input data, which is then connected to a function that splits the incoming data or payload from the Arduino to show the current and voltage through 4 independent outputs. The serial port input data is also connected to a JSON block that is used to convert the payload string to a JSON object. The JSON object is then sent to the web server by an HTTP post request to be displayed immediately on the website as a live monitoring system.
The final part of our methodology is a website that is highly secure to have an easy access way to see the live measurements from anywhere. And it can also be used to do some control operations on the system. The website was created using Spring Boot framework in the backend, which adds many powerful features to the website, like security. The website depends on REST controllers and Hibernate connected to MySQL database, and a sample front-end with TimeLeaf and JavaScript. Spring Security offers a password encoding feature. It's only one-way transformation, so the password can only be encrypted and cannot be decrypted anymore to return to its original plain text form. Also, Spring Security offers different roles for the users, and then it can limit some website features to specific rules. For example, reaching some endpoints or different HTTP requests. All the endpoints on the website are controlled by security and REST controllers, which call the service layer, and then the service layer calls the data access object, which is DAO, to connect to MySQL database. Then it creates, read, update, or delete any data from the database. MySQL database consists of 2 parts, a table for saving measurements and 3 tables for Spring Security, as shown in the UML diagram.
Now moving on to the results, the figure shows the experimental setup of the virtual instrumentation system. The microcontroller of the Arduino board gets the DC and AC output voltage and the current which are measured by the sensor which is posted in the Arduino IDE. Once the Arduino board is connected to the first computer through the USB cable, Node-RED receives the data through a serial port and is showed through the local dashboard. Node-RED also posts the data as a JSON file through the HTTPS request online to the database as seen in the second computer, which is available virtually. The local monitoring system gauges shows that the reading from the Arduino sensors read on average of 1 second interval. The results show that the data were displayed in real time, which is the actual goal of the project. As seen in this figure, the gauges are divided into 2 subsections showing both the DC line and the AC line, both showing the voltage and current. Additionally, voltage and current are presented on the SCADA screens as seen on the figure for November 19, 2022. The figure displays time in relation to the DC and AC voltage. Additionally, the variation of DC and AC currents over time can be seen as the reference point for the local host to display the measurements.
The website was deployed by Amazon Web Services, AWS, so it's now live and anyone can have access to it. On the website, there are two main roles for more security, students and professors, and it's required to have an account with any role to have access to the live measurements. But there are some limitations for the student's account, which is the default role for all the new users. For example, limiting the HTTP post requests and the access for the measurements full history page to any account with professor role only, as shown in the next slide. The REST controller can retrieve any measurement object from MySQL database by Hibernate. Then it converts the measurement object into a JSON object to be returned to an endpoint as needed to be accessible by HTTP GET requests. As shown in the figures here, the first one is for measurements list, which return all the measurements from the database. The second one is for searching, which we can use any part of the time or date to search for a specific measurement or specific list of measurements.
Finally, the proposed instrumentation system can acquire real-time data by implementing the Arduino system, monitoring and storing the data in client database for future access. Since it's less costly and time-consuming, it can replace human intervention to avoid errors associated with multimeter reading. Data therefore can be assimilated and recorded more easily with the proposed system. The performance and the operational efficiency of the hybrid power system could be improved through the analysis of such data.